Okay, welcome everyone to the Ethereum sequencing and pre-confirmation call number 3. I guess this is our 4th call now. The agenda for today is going to be in 3 parts. So we're going to have a quick update from my side in terms of the based ecosystem. So builders that are trying to leverage base sequencing and base pre-confirmations. I have some exciting updates. I'll try to keep it very brief. And then we have Alex Gruchowski from zkSync, who will be presenting his concern with base sequencing that we didn't have the time to present last time. Actually, he was on a flight, which is why he couldn't present. And I think I want to give him a bit more than 10 minutes because he's representing a roll-up, and I think there could be some interesting discussion from the points that he bring up. And then in the last 25 minutes or so, I want to give an opportunity for some of the various projects that have been building cool stuff and doing cool research to do very small presentations or small teasers on what they've been working on. So without further ado, I'm going to share the presentation. Okay, so I kind of want to give you a quick overview of what I think the base ecosystem has grown to in 2024. So at the very beginning of 2024, there was, from what I can tell, just one project in the base ecosystem. It was Tycho, and in the last few weeks, we've had 10 more projects look at it. So one which I learned about very recently, I think last week, is this this project called Rise, and they gave me a small blurb. I couldn't make it to the call. So basically, they're building a base rollup, which is a high-performance Rust-based parallel EVM rollup built on top of Ref. So this would be like after Tycho, the second publicly announced base rollup. Another really exciting development is that the founder of one of the very top rollups in production today told me a couple of days ago that they will be pushing to make their rollup based. So this is a very surprising development to me that it happened so quickly, but there we go. We also have in the base ecosystem at least 2 entities doing research. So these are consultancies that are doing research internally, but also for the various projects. So I believe LimeChain is doing a lot of great research, and actually there will be a presentation towards the end of this call by George on what he calls base ticketing, which is a new design. And we also have Nevermind that has been pushing some fantastic research on base sequencing and also working with various partners in the ecosystem. We also have infrastructure providers that seem to have pivoted in some sense to base sequencing, and we're going to have various presentations and teasers from some of these teams. So, for example, Espresso is now building a based shared sequencer. We have Sorella, which I think is more discreet about what exactly it's building, but it seems that the company has pivoted in some sense to base sequencing. Same thing with Chainbound. Very, very excited with base sequencing, and I think also still under wraps in terms of what exactly they're building. And then there's Spire, which hasn't yet pivoted to base sequencing, but they're basically considering building this base rollup app chain framework, something analogous to the OP stack for the superchain. And that native framework would basically integrate base pre-confirmations and base sequencing to make it very easy for base rollups to be created. So oh yeah, and then there's a final group of infrastructure players, which are the relays. And we have Gattaca, the team behind the Titan relay, sorry, the Titan builder, which is one of the largest builders. They recently released the Titan relay, and they're very much excited to provide additional services in addition to relaying. And Preconfirmations is one of the base Preconfirmations is one of the services that they're very excited to provide. And similarly with the ultrasound relay, currently like the most popular relay, and looking to expand beyond just relaying and provide Preconfirmations. So that's it from me, and then I guess I'll hand it over to Alex to present his concern and ensuring discussion around base sequencing.
Sure, thank you, Justin. We have let me check that we have also comment from our team here.
I'm here.
Right here, okay. So I will just share a couple of usually, and then Common, you can present the presentation. It's fine.
That's great.
Cool. So I just want to say I'm very impressed how far the progress is going, and it's very cool. It's very interesting development. I, as a builder of ZK Sync, like our mission is shared with everyone. We want to scale Ethereum while preserving the properties that make Ethereum really valuable, like what made Ethereum valuable in the first place. And the history shows that if the community does not coalesce around certain values and pushes for them, they can deteriorate with time. And so like one big thing which we discussed with Justin throughout the last 2 years, but in discussions of base sequencing, is that it might lead to a bit more of centralization, because you create an infrastructure that makes centralization easier. If you make infrastructure that makes it harder, then you can, for example, like you can make design choices that favor solo stakers, or you can make design choices that don't favor them, and like make it very, very easy to delegate and restake, and then you will end up in a situation where like a lot of stake is governed centrally, right? So if you make base sequencing, let's imagine base sequencing wins, it would be very important to make sure that the builders cannot be evil. Because if builders can be evil and all of the rollups are sharing the same building infrastructure and effectively acting as one huge sharded rollup, we might end up in a situation.
Yeah, yeah.
Sorry about that. The person's been muted now.
I see. So like the way we see it with like if you have shared sequencing, if everyone is using shared sequencing infrastructure, that effectively means you have like one huge system that is sharded and that is operated essentially by like a few big entities. And there's a really big risk that then Ethereum turns into like big tech chain, right? Where those guys have a lot of subtle power. If they process all of the transactions from the users, they could be censoring users, they could be doing a lot of bad things, right? So, which we know that there are tendencies towards this. We know that most of the blocks in Ethereum are being processed by entities that are, for example, OFAC compliant, right? And then today it's just Tornado Cash, but tomorrow it can be anything, and like the list can grow, and then it can be real time, and like specific users can be targeted for political reasons, or maybe just because like it already happened that the like OFAC compliance leads to using of certain companies that provide this, and then those companies can have like false positives and false negatives, and they can exclude your users without them actually doing anything illegal. And then those companies get a lot of power all of a sudden because they start to dictate, and they can like subtly tweak the parameters in a certain way, which will favor certain players over the other players, right? So my first like concern or proposal would be like if this is the route to which Ethereum is going, then it would be really important to focus on first making sequencing trustless, like work on the mechanisms that would make it impossible for sequencers to be evil, meaning some form of embedded censorship resistance, like either through cryptography or through some mechanisms, but that are working at the sequencer layer. I think it's not enough to say like censorship resistance is going to be solved by like extra mechanisms where, oh, if you're being censored, you can send this transaction to the validators. Because if shared sequencing becomes, or shared sequencing with based rollups with preconfirmations becomes ubiquitous, then most wallets will switch to this. Most payment providers will switch to this. And then like users who cannot participate in this like 1 second confirmation thing will be essentially excluded from the economy. So like this is generally like it's a very general concern. Like we can like I mean I just want to kind of like leave it open and for discussion and see what you guys think. But I feel that it's very important to first focus on those. Like with rollups, we have this experience where rollup space started as something very focused on preserving the security and decentralization properties of Ethereum. And then the first rollups started essentially like some rollups started in a way that did not really work like rollups, right? Like did not have fraud proofs, for example. And then everyone said like, sure, like, well, it's just going to be implemented in a very short time. It's okay. Like, let's just build fast, iterate, build MVP, and try things. But it gets sticky, right? And like some of the rollups still don't have fraud proofs. And I think most of the big optimistic rollups still don't have permissionless fraud proofs, which makes them essentially, like very similar to side chains with very high threshold of operation. And this puts a lot of pressure on everyone. This puts a lot of pressure on us. Like when we have to prioritize our roadmap, we have to choose between transitioning to stage 1, stage 2 roll up and like making sure that it's properly decentralized, or like building something that will have, like the space is very competitive and like building features that will create some like, interesting advantages for the product, for the platform, for the network. And I think it's not in our power to change this. Like it's in the power of the community to create pressure on everyone to comply with certain values of Ethereum, to comply with these decentralization approaches. And I'm just like having gone through this with rollups, I really want to make sure, like from my side, like I will be doing everything to coordinate community, like push community to actually enforce those values before they actually get implemented. So that's one concern. And the other concern is when we build a system, like I would love to understand what's the end game. Is the end game that everyone switches to base rollups? Or is the end game that Ethereum is a plurality network where the original idea of rollup-centric world, where rollups can permissionlessly innovate and go in different directions, is still valued by the community and embraced? And if that's the case, then the second big thing that would be very important to preserve is connectivity between the different systems and the ability, like the right to exit. The way you can think of blockchains, like why blockchains are great as network states, as like with all the on-chain governance, is that you can always exit. On layer 1, your exit strategy is a fork. Like you don't like what the validators of Bitcoin are doing, you don't like they start censoring users, or on Ethereum they do something bad. You can always say, you know what, like I don't like this rules. I'm excluded here. I can fork a system, change the set of validators, and continue there. On rollups, it's even easier. You just withdraw to layer 1 and you withdraw to other rollups, and like the ideally we build a system that is much more interoperable between the rollups, but in a way that does not force everyone to go and become, a essentially one single system, like embrace completely the same architecture, the same approach to sequencing. It would be great to have alternative approaches, like alternative systems, alternative sequencing methods that are still interoperable with this, like whatever mainstream movement is. And here we have an idea to propose, but maybe it's worth to first open the floor for questions, discuss generally, like the general concerns. I think there are lots of people who want to share.
Noah, you have your hand up.
Yeah, so one of the things that I wanted to bring up with like the censorship resistance around shared sequencing and PBS in particular, Alex's concerns, is I do think adding censorship resistance at the roll-up level is something that's really interesting. One of the things, I know Alex didn't bring it up, but one of the things that I've seen recently that CK Sync really CK later on is having censorship resistance around certain matching. I think that adding additional features like that could be less and less on.
Yeah, you know what? It might be nice if you slow down a little bit because your audio is cutting out in and out a little bit.
The audio is not good. Can you use a different microphone, maybe?
Okay.
Is this working better?
So much better.
Okay, great. Sorry about that. So to go back to start, the concerns around PBS, I believe, are completely valid. And I think that one of the things I've seen recently is ZK Sync just collaborated for a rollup called ZK Lighter, which has censorship resistance built into their own AMM with ZK circuits. I think additional features like that could be a great way of essentially having better censorship resistance. But it also comes around the rollups block building rules at the end of the day. So I think a lot of these systems that we're building, whether it's Espresso shared sequencer, Node shared sequencer, or any of these other options on the market, really want to be maximally lazy in a sense. So we don't want to have too many things enshrined and too many things added onto the system itself. So I think a lot of these primitives for better censorship resistance can be added on, and you can still fork away. At least for our system, you can use Alt-DA and you can fork away from our system. So I believe that those will help out with the censorship resistance and being able to say like, hey, I don't like this, I want to leave. But I do think they're valid concerns. I do think that over time, there will be better systems that get developed. And the best way for a shared sequencer or a base sequencer, in this case, to really function is to be maximally lazy in a lot of these things and not tell the rollups, hey, this is the way you have to do things forever and you can never fork away. Because just like with any of these things, with these large decentralized systems, like just how Ethereum operates today, getting everybody to agree on one thing will be next to impossible. So I think that having maximal optionality makes a ton of sense. It will really help every rollup be happy with the solution that they choose instead of all going with one or the other.
I guess what you're saying, Noah, is that it would be nice if the shared sequencers or sequencers be minimally opinionated, so it leaves as much room as possible for each individual rollup to come up with their own encrypted mempool or their own inclusion list strategy or whatever it is.
Exactly.
Ben, you have your hand up.
Yes, thank you. And Alex, thanks very much for coming here and presenting. That I think that the concerns that you're sharing are something that we all share too, and I think it's very important that we're having this discussion. I think that one thing to consider is if every rollup is anyways going to decentralize its sequencing, then and Alex, I think you and I maybe discussed this before at some point, but it creates pressure anyways for builders to try to build for multiple ecosystems at the same time. And in fact, if you're looking at builders who are going to try to participate and win slots for multiple rollups that have decentralized sequencing at the same time, it's going to narrow the builder set even more. Because the builders that are most well capitalized and most able to simultaneously win these different sequencing slots at the same time are going to be just an even smaller set. And because there's going to be market pressure on builders to do this, because they can offer these additional benefits to users when they're producing rollup blocks from multiple rollups at the same time, it's going to happen. And so in some ways, what I view as shared sequencing is some kind of coordination to allow more participation in this marketplace. Which brings me to the second point. I think that we have sort of made a mistake as a community in calling this a shared sequencer. And in fact, Espresso is moving away from the term shared sequencer. What Espresso is really doing is building a marketplace for shared sequencing, and this is compatible as well with the idea of based rollups. Maybe not as the original way it was described, but if you think about any of this infrastructure as creating a marketplace where sovereign rollups have autonomy over their own block space and can sell block proposal rights to third parties, including the L1 proposer, that is really what shared sequencing is. So rollups that are participating in such a marketplace can produce blocks on their own sometime. And if it suits them for synchronous composability or other reasons, they can sell blocks, sell block proposal slots to other common proposers. Some rollups may choose to sell this all the time, right? And be like the most based if they're selling it. By the way, the difference between a based rollup and a non-based rollup is really mostly about whether you're reorging with the L1 or not. So if rollups are building off an older L1 state for the benefits of stronger finality, then the L1 proposer is not able to construct, even to buy the rights to propose for them at the same time, because the L1 is ahead of the rollup in some sense. Whereas rollups that reorg with the L1 and sacrifice this faster finality, they can sell block proposal slots to the L1 proposer. So anyways, I know that's not necessarily how everyone is thinking about this, but that's how I'm thinking about this. And I think I'm coming from the very same place as you are, Alex, in the sense that I think enshrining one infrastructure to control all rollups is definitely concerning. And you bring up a very good point. But I don't think that's the direction the industry needs to go in. It can be in this more ad hoc shared sequencing model that I'm describing here.
So if I were to summarize one of your key points, Ben, you're saying that if there is demand for synchronous composability, there is going to be demand for shared sequencing. And that's going to happen no matter what. And the question is this going to happen through like extreme sophistication with people building like additional layers and like extreme centralization? Or can we build this coordination infrastructure that actually dramatically lowers the barrier to entry to facilitate this shared sequencing? And in some sense, we're removing complexity and reducing the barrier to entry.
Yeah, that's point number one. And I think point number two is that it's not shared sequencers as one infrastructure. Even base rollups don't need to be enshrining the L1 as the sequencer for all rollups. It's more that sovereign rollups can sell proposal slots dynamically. And if they're reorging with the L1, they can even sell it to the L1 proposer.
Gotcha. So you're saying, base sequencing is not all or nothing. You don't have to like always be based. Like you can choose when you want to be based, and you can open it up to the market to decide where to allocate these resources as optimally as possible. George, you have your hand up.
Yeah, thank you, Justin. Hey, Alex, nice to meet you. I'll actually go on the other direction and approach this from engineering standpoint. And I'm not totally sold on your point where you say, well, once we are figuring out how to do base sequencing or whatever is sequencing, let's figure out also censorship resistance. So for the past, I don't know, weeks or months, we've been trying to figure out how to do just sequencing that is possibly enabling universal synchronous composability and is possibly decentralized or at least has minimal training wheels. And I am very skeptical that if we also tag along the requirement for base sequencing to be completely censorship resistant, we are not going to be super overcomplicating the whole thing. So from engineering standpoint, I'm not totally sold that we can actually do this without hampering the rest of the requirements that we have for sequencing. Does this make sense?
As an engineer, I have to agree with you. As like someone who cares about Ethereum, like this is exactly my concern. Like to put it
I
bluntly,
wonder
turn Ethereum into a KYC chain.
I wonder whether these can be sequentially addressed though.
It can't. Like once you do something that you know, like that is easy to do, like and like takes traction. It's like so basically today Ethereum is decentralized, right? Like whether you have validators, you have like everyone is building something in a decentralized manner. You have some people who follow the censorship, some people who don't. Like the Tornado Cash blocks, like I'm not advocating for Tornado Cash for the record, right? But like just using them as an example.
Yeah, it's an example.
Still being built, right? In a world where the Ethereum is essentially sequenced by a few big tech providers, there will be 0 blocks with Tornado Cash. And with like whoever those 3 guys don't like or whoever their bosses don't like. And like this is just reality. Like this is what's gonna happen. Like take me on record. This is what's gonna happen if this is the future we're going down. Like without first building something that like makes the sequencer not able to be evil, they will become evil. We've been there with the internet. We've been there with blockchains here as well. Right. So like this is precisely the concern. Like this is why Ethereum has spent so much time, and Bitcoin, I mean, the entire Bitcoin philosophy is based on this, like cypherpunk, in and out, like above everything else, right? Ethereum initially has spent a lot of time on thinking about this specific problem. How do we prevent censorship? How do we prevent capture by big tech, by like centralizing forces? Like how why not just like increase the block space as much as you want so that you have a few entities, you know, like you could do the same thing as like Bitcoin Cash, right? And that was specifically deliberately not done in order to keep Ethereum cypherpunk or like free, you know, sovereign, decentralized. This development for the reasons, George, which you mentioned, is exactly what I'm concerned about. Because like
Okay.
it tends to like we tend to go down the route which is easier, in which like market forces are pushing us. And if there is no pushback from the community, this is exactly what's going to happen.
Okay, makes sense.
So Alex, I guess what you're saying is that there's path dependency here. So either we figure out censorship first, or we risk like never figuring it out.
Yes.
I mean, from my perspective, I think we already have you know, a censorship problem at layer 1 with the builders. But that leads to what I call weak censorship, where basically transactions have delayed inclusion, but they're not completely censored from the chain. And I don't think we'll ever have strong censorship. Now, weak censorship, even though the name has the word weak in it, is still, you know, extremely important to tackle. And I think the 2 best technologies that we have are number 1, inclusion lists, and number 2, encrypted mempools. And I think like these are being like worked on and also prioritized. So for example, Mike Nuder is really making a big push towards inclusion lists. Now, inclusion lists, admittedly, does require some sort of special path, some sort of mechanism whereby, you know, transactions can be gossiped to a public mempool and then picked up by the proposers, as opposed to the preconfirmation system, which is more of a peer-to-peer, end-to-end encrypted connection with a well-defined entity. And so I think you're right. Like we need to be building both paths in parallel and not just one. Otherwise, we risk ending up with just the one path, which, as you said, there's the power of the default, where like wallets will just bother integrating the simplest one, which covers 99% of users, and then a minority risk getting censored.
Yeah, so like I think the inclusion lists work for specialized players, like for rollups who want to submit transaction. Like if a rollup is being censored, inclusion list is probably a good way to enforce that this doesn't happen, but not for the end users. And so it's even more important to make sure that, like, if this is the market forces are pushing us down this route, let's just make sure that there are alternative ways to build rollups, and people who want to build them are not excluded completely from this economy, and there are ways to interoperate.
Right. I mean, I guess one observation is that this concern around censorship applies generally to decentralized sequencing, not just to shared sequencing. If you have a decentralized sequencer with PBS, you want to have censorship resistance baked in, and
Yes.
And so I guess I think there's consensus that we want to have decentralized sequencers, and so as a community, we definitely need to solve this.
And like we have spent some time thinking about this problem, and we came to the conclusion that you can't really decouple censorship resistance from the protocol itself. So you cannot build a like a sequencing layer which is completely like agnostic towards the fact whether there is censorship or not. Like it must be part of the protocol.
Murat, you have your hand up.
Yeah, thank you. So we've been thinking about this particular issue as we had applied for the Tycho grant for the pre-confirmations on L1, and based on some of the discussions that came out of this group, actually, we positioned those to be a potential relay providing these pre-confirmations, and then creating essentially a constraint for the builders that the relay is working with. So that's kind of the basis of our proposal there, that Tycho transactions would essentially go to a relay which would then create some constraints on the builders that it's working with. And this sort of works as a minimum viable inclusion list, if you will. So I'm wondering if there's a line where we can draw somewhere saying, hey, look, this path is satisfactorily kind of censorship resistance enough to move forward. Or, and the question is to Alex, do you think that falls under the same kind of path dependency where it all breaks down because it's not fully censorship resistant path?
I don't quite yet understand the idea. I would love to learn more.
Okay, yeah, maybe we can do that offline, but yeah, for the community, there's active work in this area where we're talking to relays to figure out if we can enforce some rules from the relay to the builder, perhaps in a less kind of profit decaying way with L2 sequencing and other kind of less DeFi or MEVI constraints.
Carmen, did you say you had a presentation ready?
Yes, it's
if you want, you can have 5 minutes if you can fit it in.
Can you see the screen?
Yes, we can see the screen. Yes.
The presentation, right?
We can see your calendar.
Okay. Just a second. How about now?
It's loading. Yes.
Okay, so I'll try to be very brief. So a prerequisite for universal synchronous composability is layer 2 interoperability. And tying into the previous conversation, we have to create this shared sequencing interoperability standards in a way that not everybody has to participate in base sequencing, but we have to let every flower bloom, basically. So interoperability is making about layer 2's borderless, and layer 2 standards and interoperability fit into our previous conversation based on this diagram. So it's kind of adjacent to it. It's not directly the same topic as sequencing. And I want to present the deposit sharing idea today, which would allow interoperability between different layer 2s. But just this ties into our previous conversation with universal synchronous composability, because universal synchronous composability is only possible in the intersection of the two topics. So we need both based sequencing for universal synchronous composability and L2 standards and interoperability. And L2 standards would allow asynchronous interoperability between different chains, which would already be a huge benefit for them. So let's look at the basic problem in this area. The biggest problem is liquidity fragmentation. If you have two different chains, then they will have two different bridges on layer 1. And if you're transferring value between one rule up to another, then you have to transfer it on the bridges as well. This problem has to be solved. And the biggest question when it comes to layer 2 interoperability is how do you solve this layer 1 transaction problem? So for a single ecosystem, just to get everyone up to speed, inside a single ecosystem, inside a different single governance and trust zone, you can use a shared layer 1 shared bridge and shared transaction route. This transaction route commits to all the transactions happening inside the ecosystem. And using this, you can do what we call hyperbridging. Other ecosystems call it LXLY bridging, but it allows cheap and trustless transactions to go from one rollup to another. So this is possible inside a single ecosystem. The big question is how to do it between different ecosystems. Our solution for this is an shared bridge coupled with an asset verifier. This is Alex's idea. And basically what this would allow is permissionless VM verifiers on layer 1, which would be decoupled from verifying the fact that each chain will have its balances verified together in the shared bridge. And using this system, the VM verifier can be permissionlessly deployed and arbitrary. The transaction route would still commit to this transaction inside the whole ecosystem, and the bridging process between the different rollups would still be the same. So this is the first idea, and there's another idea, and this is Jordi's idea, which is to have mass deposits between different bridges. Basically, in this idea, a rollup would commit to its transactions in the transaction route, and then there would be a mass transfer from one bridge, and it would go into a mass deposit handler contract on layer 1, and the destination rollup could then withdraw these mass deposits and could then receive the transactions from this mass deposit handler. So basically, I wanted to show these two ideas to get this conversation started and to have people understand the two basic options that will be necessary, that are the two options for universal synchronous composability. We think that asset verifiers are better than mass deposits. They do require a bit more coordination because the asset verifier, which is a proof verifier contract, has to be standardized. This could be a multi-verifier situation, making it easier to coordinate, but it has multiple advantages. And basically, the next steps are to decide on how to solve this liquidity fragmentation problem. So I think this is the first step. We should discuss it, go over it, and then there are further steps, but because of the shortness of time, I will skip these. So thank you very much.
Thank you, Carmen. So I guess what you're saying is that in order for universal synchronous composability to really be practical, in terms of transfer assets in and out of these rollup ecosystems, we need the asset transfers to be much more efficient. If you go through the L1 every single time, it becomes extremely expensive. And there's basically two solutions. We can either do batching, we have these mass deposits, or we can have some sort of shared deposit layer with a minimal verifier who's only is responsible for the assets and not the rest of the logic. Thank you so much. I think this could be a great discussion starter for offline discussions or future discussions on these calls.
I created the group. I will share a link in this chat here, and then you can guys add anyone else who is not participating in call, and maybe we can start discussing there. I think this would be an important addition to the work in parallel to shared sequencing to make sure that we're making calls.
Okay, perfect. Thank you, Alex. We'll make sure to include those in the PM notes on GitHub. I guess now is the time for some announcements and updates and teasers from various teams doing cool stuff. So I guess I'd like to invite Espresso first to give a 3-minute pitch on what they've been working on.
Sure, Justin. I don't think I really need 3 minutes, but I was able to highlight this a bit in the context of Alex's presentation as well. But what Espresso is creating here is more of a marketplace for rollups, sovereign rollups, to be able to participate in what I call ad hoc shared sequencing. I know that there's been different debates on, is there going to be value in shared proposers proposing for multiple rollups at the same time? Maybe there's no value. I mean, this is something that Yi brought up in the chat as well. Maybe there isn't cross-domain MEV. I think the value in being a shared proposer for two rollups goes beyond MEV. It goes to everything that has to do with preconfirmations, as we've been talking about. And maybe between some rollups, there won't be value in having a shared proposer. A marketplace is something that can determine this, right? You may have rollups that are not selling block proposal rights because nobody is bidding on them, and they're just producing their own blocks. You may have other rollups which are selling their block proposal rights to common third parties that end up proposing for multiple rollups at the same time. And this is the framework through which I view based sequencing as well, because based sequencing is a special case where the L1 proposer is able to create surplus value for rollups by being able to simultaneously construct L1 blocks and rollup blocks at the same time. You might have some rollups that don't benefit from that, right? You might have rollups that really don't benefit from synchronous composability with L1 contracts, in which case those rollups may not end up selling their proposal rights to the L1 proposer. And you know what? Maybe those rollups will at some point find that there is a reason in some slot to do this, and that may dynamically happen. So all in all, Espresso is really viewing this as, let's just create a marketplace. What does a marketplace require? Well, it requires coordination at the level of, we can advertise our block space, and if some common proposer is able to buy block space from multiple rollups at the same time to become a shared proposer, then that needs to be recognized, right? So we need some kind of finality over that. What enables the L1 proposer to be able to participate? Well, the one tricky thing is that if you run this marketplace too far in advance, then the L1 proposers aren't known, right? So on the other hand, if you don't run the marketplace too far in advance, then preconfirmations, you have less time to run kind of this sale process, and so that you might run into efficiency issues, and also you give less of a look ahead time for parties to start giving out preconfirmations of what they're going to do during their turn. So if you want to run preconfirmations, further than if you want to run this proposer marketplace further than 32 slots in advance, then you can always just give the L1 proposer what we call a right of first refusal, which is the ability to buy any proposal rights from any other player when it becomes known that this will be the L1 proposer. And so finally, what makes a rollup a based rollup versus a non-based rollup within this marketplace is simply their decision on whether they are going to reorg with the L1, so allow the latest L1 block to have an impact on the rollup, versus not reorging on the L1. If you don't reorg on the L1, you could still sell your block proposal rights to the L1 proposer, but it would not allow for synchronous composability with the L1. The synchronous composability only comes from the ability of the L1 proposer to simultaneously construct the L1 block and the L2 block in such a way that actions it takes in the L1 block can actually have an impact directly on the rollup. You can do a deposit and withdrawal, let's say, from the rollup in the same block. It also relies on real-time proving, or perhaps something like proof aggregation, as long as we can get it down to less than 12 seconds. So that's a quick summary, and I'll be posting I've shared the preliminary version of a HackMD post that describes this idea in this channel multiple times, but we're actually just publishing a blog on this today. It should have already gone out, in fact, and I'll send the link towards the end.
Perfect. Very exciting. Looking forward to read the blog post, and we'll add it in the show notes links. I guess next up for a real quick teaser is Alex from the ultrasound team.
Yeah, hi. Yeah, I'll keep it really short and just share what we as ultrasound see for areas where we can contribute. I'd say we're very much like in the exploring phase for how to contribute to this and interested in building or helping build an MVP of doing this. So I'd say like pre-confirmations where this is really close to the block building and pricing, especially the tips. Like it'll require a lot of hardware, a lot of specialization, and that's not something that all proposers will have like equal access to. And as a proposer, you'll have to pick a party that you're doing these pre-confirmations with. And then even if you only know relays for how we're trusting them, and that's what you don't like them, if you want to minimize trust, relays are already this party that many proposers are looking at closely to decide whether they trust them. And then this is a role that a relay could fulfill as well. And then second, of course, is reliability, especially if on the user side, we get very used to having these very quick pre-confirmations. But also just for the MEV to arrive uninterrupted, to make sure that the block builders are informed on what transactions are pre-confirmed. And then finally, of course, that this product that they build together that lands on chain, this is all stuff that you want to be done like very, very reliably. I think we recently hit like 1 million blocks landed, so very happy with that. Reliability seems to be important. I also imagine, I heard censorship resistant came up. Like in protocol, much nicer, but it would of course be very unfortunate if one of the most successful, one of the most liked pre-confirming parties is also the one that likes to censor a lot. So I think that's another area that we take very seriously and where we might be able to contribute by following the Ethereum ethos of doing something about censorship. Also, the pricing of pre-confirmation tips, the rebates that people might get. Relays are maybe not the party to do this, but we're already connected to the parties that might be really good at this, the block builders. So I see that as a benefit. And maybe relays might even be able to facilitate a sort of neutral tip/rebate auction mechanism. I think that could be really cool. So like, yeah, finally, if you as a proposer want to unlock these things for the Ethereum network, the virtually instant transaction pre-confirmations, the better composability, the better atomicity, and then you're going to need some infrastructure to do that. And then if you want that to be infrastructure that you can trust minimally, we want to at least allow proposers to be able to do that with us. So I think that summarizes it.
Perfect. Thank you, Alex. Next up, I want to give you a quick announcement on some of the events happening in London in the next few days. So on the 12th, 13th, 14th, and 15th, there's 4 different MEV events. So it's going to be a packed week ahead of ETH London. So if you are in ETH London, please send me a DM. The one on the 12th is MEV.market. On the 13th, there's an event that's kind of tailored for the rollup project. So if you're part of a rollup team, there will be a whole day of workshops dedicated to base sequencing and based pre-confirmations. And we have most rollup projects represented, most of them actually with their founders coming. So if you're part of a rollup team but not yet coming and you are in London, please send me a DM. And then next up, we have George from LimeChain, who will be talking about his new design, teasing based tickets. George, I think you're muted.
Sorry, yeah, you see my screen?
Yes, we see it.
All right, we'll try to fit in 5 minutes. So for the last couple of weeks, we've been working on an idea that we call the base ticketing rollup. it came out of several realizations. First of all, is that we like a lot based sequencing rollups. However, as we were exploring more and more about preconfirmations, we figured out that like there are certain pieces of the concept that make it hard to start with this concept, and also make it a little bit hard to actually adopt this concept. One of these things is, for example, the gap between L1 proposers that are actually going to be L2 proposers. And with the help from the folks from school, namely Mo, we were able to come up with a concept that's called base ticketing, and I'm going to give you the TLDR of this concept. It is essentially combining the base rollup with execution tickets concept. Any rollup can decide to offer two types of tickets. One type of ticket is called the proposal tickets. The other types of tickets are called the enforcement tickets. So the proposal tickets, the parties that hold the proposal tickets are actually eligible to be drawn to be the next proposer of this rollup, the base ticketing rollup, and they can essentially propose the transactions list. The enforcement ticket holders actually have the rights to constrain the block that the proposal ticket holder is going to propose. So the enforcement ticket holders, the enforcers, can actually provide various UX services like preconfirmations, but not just regular inclusion preconfirmations, but they can now start constraining the upcoming block through things like post-state commitments, and even to stuff like universal synchronous composability. So if there are multiple rollups that are base ticketing rollups, if a single entity actually holds the proposal and or enforcement tickets of these rollups at the same slot, they can actually ensure atomicity of both rollups, and they can ensure the atomic execution and messaging between these rollups. So this concept essentially tries to leverage the best from both base sequencing and execution tickets. Obviously, there is much more than this. I'll throw the link to the first draft. We are currently supported by Ethereum Foundation for this research. So all of our research is going to go live quite soon, even this draft. We are pretty much halfway there in defining the various flows that are there, and also exploring the various mechanistical infrastructure that is needed in order for this to happen, and the changes around the MEV pipeline. So yeah, stay tuned.
Perfect. Thank you, George. I guess we have a couple minutes either for questions or for another project who's been doing based sequencing stuff, who wants to have an opportunity to present their work. Mohammed.
Yeah, I just want to ask a few questions from the audience. So one is, when we talk about synchronous composability, are we talking about different rollups being able to synchronously read and write to the state of the other rollup, or are we just talking about this specific type of state manipulation that's sharing liquidity and transferring assets, which is only possible if we put that subset of a state in a very specific location? Because like from the presentation of the Kalman and some thoughts shared by Alex, I'm not sure which direction we are going. And that's one. And second, it seems like there is some discussions in the chat around like whether MEV is the biggest thing we want to get out of this shared sequencing, like cross-chain MEV, or whether market forces that are forcing us to do this shared sequencing are cross-chain MEVs and so on. So I want to put this thought out that like if we enable synchronous composability in the sense that we could manipulate the other chain's state, then like we enable a new market force that makes shared sequencing very sexy, and like without that it's quite kind of useless. in my opinion. And like it boils down to figuring out if we want this like a strong notion of synchronous composability or not, and whether this is in conflict with other ethos like censorship resistance and so on. So I guess like focusing on shared some layer for shared assets or easier transfer of assets is like missing the bigger point. I'm not sure what are your thoughts about it.
Right. Okay. Let me try and answer those questions. So I guess the first one is like, what is the definition of synchronous composability? And for me, is the ability, as you said, for one rollup to have access to the state of another rollup to either read the state or to write the state. But this is not done explicitly in the sense that there isn't like one transaction that will, it can't have rollup A within its own rollup A transaction read and write state to rollup B. Instead, you have this notion of a super transaction, which is the concatenation of sub-transactions. And each sub-transaction is specific to one single rollup. And the synchronous composability is basically simulated or emulated or given to you by the shared sequencer. Because they have monopoly rights to sequence on all the rollups, and so they can make sure that these sub-transactions within a super transaction are all as they should be. Now, in terms of reading the state of another rollup, this is done trustlessly using SNARKs. So when you have real-time settlement, you can pass the state root plus a STARK, proving that it's correct. Now, in terms of, I think, the second question, which is like, are we going for just simple asset transfers, or are we going for something much more expressive? Like, we're going for like the thing that's maximally expressive. So you can do arbitrary calls from arbitrary contracts between arbitrary rollups. So it's a little bit like today, where you could have any contract called Uniswap or Aave and have like an immediate and synchronous response. But all of that is simulated economically, and so users have to pay for the overhead of synchronous composability, which could involve adding locks. So if you have a super transaction over rollups A and B that is blocking both rollups simultaneously, well, the user is going to have to pay gas on both rollups while that super transaction is being executed, even though internally to a super rollup there's only one transaction that's executed at a time. And so that's going to lead to a market where basically you have the sequencers selling synchronous composable locking mechanisms, and you have arbitrageurs and users and whoever it is who will be buying those virtual locks.
Yeah, I mean, just one more thing. I want to also like say that like it's not necessary that we have like this super transaction kind of design necessarily. Like from my perspective, there is like this strawman construction. I call it intermittent fusion. Like say all the rollups agree on some very simple VM, and this VM is some extension to their like VM rules or some subset of them VM rules. All of them agree with. And every 10 blocks or every 100 block or every once in a while that somebody is able to pay off all these rollups, this a small VM comes into play and manipulates the state, which some values written somewhere, and they all finalize on this intermittent fused like a small VM. Like, I'm not saying that this is a perfect design, but I'm just saying that you could have like a design without super transactions per se that does this, I guess.
Yeah, I mean, I think this is what the asset verifier is all about. You have like a minimal VM, which only handles the asset deposits. I think that's the ZK Sync idea. Like one of the downsides of like sharing VMs is that now suddenly you share bugs, you share security assumptions. You might, and so really what you want is have very, very clean boundaries between the rollups, so that each rollup has different security assumptions and has its own independent governance and whatnot.
Makes sense.
Perfect. I think we're at the hour, so the public call is finishing now, but we have half an hour of after discussion. So I guess I'll open it up to the floor to whoever wants to bring a topic up.